compare and order rational and irrational numbers. Think about this question during the lesson. Darcy wants to add this ribbon along the diagonal of the rectangular flag she's designing. Does Darcy have enough ribbon? Here's what Darcy knows. The flag is 7 feet wide by 5 feet high, and Darcy has 8 5/10 feet of ribbon. 7 squared plus 5 squared is 74. So the diagonal on the flag is the square root of 74. Darcy needs to approximate the square root of 74 to compare it to the length of ribbon. Why? "74 is not a perfect square. So the square root of 74 is an irrational number. Therefore, you need to use a decimal approximation to compare it to 8 5/10. So Darcy can use a number line to approximate the square root of 74 using perfect squares. Because the square root of 74 lies between the two consecutive perfect squares 64 and 81, the square root of 74 is located somewhere between. Which integer is the square root of 74 closer to?
Select your answer.
Because 74 is closer to 81 than 64, the square root of 74 is closer to the square root of 81, or 9. We don't know exactly where, just that it's closer to 9 than 8. Now that she knows the square root of 74 is between 8 feet and 9 feet, can Darcy tell if she has enough ribbon? Darcy needs a better approximation of the square root of 74. She can get a better approximation by squaring decimals between 8 and 9, then comparing them. Darcy squares 8 5/10 and gets 72 25/100. That's too low. So she squares 8 6/10, which is 73 96/100. That's really close to 74. Darcy is disappointed because the length of the diagonal, the square root of 74, is about 8 6/10 feet. She doesn't have enough ribbon.
Between which two whole numbers is the square root of 12?
Okay, for this, I would have to start out with the square root. So the square root of 12 is like 3 point something, something, something. So the two whole numbers it would be between would be 3 and 4. So to find the square root of a number that equals 3, we got to do the perfect square of 9. And then to get 4 would be the perfect square of 16. And so then the whole numbers up here would be 9 and 16. I just had to kind of work backwards.
Compare and order the numbers below. Pi squared, 9 1/2, 9 8/10, 9 5/10 repeating, the square root of 94.
So step 1, use the rational approximation to estimate the values of the irrational numbers. So pi is approximately 3.14, and then you square it. So you multiply it by itself, you get this number. Excuse me. And they got approximately, between 9.5 and 9.8 and 9 and 5 repeating. And then the square root of 94 is equal to approximately 9 7/10. Step 2 will be to plot each approximation on the number line. So all of these approximations here are placed on the number line, and then you order them based on how they are on the number line. So that's how you would compare and order them.
Plot, compare, and order the values of the expressions. 1 plus the square root of 30, 2 pi, the square root of 147 minus 6, 21 divided by the square root of 10.
When you add, subtract, multiply, or divide a non-zero rational number and an irrational number, the result is always an irrational number. So use a rational approximation to estimate the value of each expression. So we have 1 plus the square root of 30. You have to find the square root of 30. It's about 5 and 5/10, and then you add. And so then we have 2 pi. So we do 2 times 3.14. Then you have the square root of 147 minus 6. That's about 12 and 1/10 minus the 6. You get that. And then you have 21 divided by 10, square root of 10, and that's square root of 10 is approximately 3 and 2/10. So 21 divided by 3 and 2/10 is approximately 6 and 56/100. Then you plot these on a number line, and then you could order them based on how they're on the number line. Okay, so interesting. So I have to use this gadget. Okay, so plot, compare, and order the numbers and values of the expressions. I'm going to drag them to the number line. Okay, so I use my calculator to find the decimal versions of these here so I can place them on the number line. So -2/5 is supposed to be on the line, is right here. All right, that was the easiest one to plot. And then you have pi minus 3, so you do pi minus 3, and the calculator came out to like 0. It was like 0. It wasn't even like 0.1 yet. It was like 0.0 something something. So that's where I plotted it. If you want to know the exact number, I'll do it again. So pi minus 3. It was 0.14. So that's about there-ish. And then 3 1/5, so 1 divided by 5 gives you 0.2. So 3.2 I put about here. It's almost a 3.5. And then the square root of 37 was like 6 point something. It was 6 point something. And so I plotted it there. And then for 2 times the square root of 11, I found the square root of 11 and then multiplied it by 2. And it was like 6.6 something. So that's how you plot them after you solve them or evaluate them, and then you graph them like this. And that's it.